Okay, so here's the first problem. A pole tilts towards the sun at an 8-degree angle from the vertical, and it casts a 22-foot shadow. The angle of elevation from the shadow to the top of the pole is 43 degrees. How tall is the pole? So we're trying to find h, which is the height of this pole, which will be this side of our triangle. So it gives us two angles to work with. It gives us the angle of elevation, which is if you were at eye level down here, that would be this angle looking up, and that angle is 43 degrees. And then down here, it casts a 22-foot shadow, so that's already written in right there. And if the pole is an 8-degree angle towards the sun, that means it's a 90-degree angle, but with just like a little bit more that way, so it'll be a 98-degree angle over here. And if you subtract all of those angles from 180, you get 39 degrees up here, which is the final missing angle. So with these angles, to find h, you would have to do the law of sines. So you would put 43 degrees here to find that height of h. And you already have a length, so we can put 22 feet there. And then this corresponding angle is the 39 degrees that we just found. So then you would cross multiply those, and that gives you sine of 43 degrees times 22, and h sine 39 degrees. So then you would multiply these two, which gives you a 14.96. And then on the other side, the sine of 39 is 0.63. And then you would just divide this over. These two cancel out. So when you divide 14.96 divided by 0.63, you get 23.76, which would be your h, which would be your height of your pole. So the next problem has to do with bearings, and it says the course for a boat race starts at point A and then proceeds in the direction south 61 degrees west to point B, and then in the direction south 42 degrees east to point C, and finally back to A. Point B lies 10 kilometers away from point A, and we're supposed to approximate the total distance of the race course. So first, I labeled these distances so they were easy to find. We just need to find these two distances and then add them all together to find the total distance. So you would use law of sines, but first you have to use the angles given up here and find the angles in the triangle, so with your bearings. So this angle right here goes here. And when you draw your bearing, it creates a 90-degree angle. So when you subtract 61 from 90, you get 29 degrees. And then over here, this bearing given right here goes there. And when you subtract, you draw a right triangle over here. I found this is the easiest way to do it. And that would be a 90-degree angle if you drew a right triangle. And if you subtract 42 from 90 to get this angle over here, that'd be 48 degrees. And then that also forms a 90-degree angle. And if you subtract 48 from 90, you get 42. And then if you subtract 29 and 42 from 180, you get your angle over here, which is 109 degrees. Okay, so now that we have the angles in our triangle, we can use law of sines to find, let's do the distance of A first. So to find your A, the corresponding angle to that would be 29 degrees. And then across from the 10 kilometers, that is 42 degrees. And when you cross multiply, that gives you sine of 29 degrees times 10. And A times the sine of 42 degrees. And then when you multiply these together, you get 4.85 equals a 0.67. And then when you divide this over, this cancels out. And when you divide 4.85 by 0.67, you get 7.24 kilometers. So that is your distance for A. And then to find B over here, you would take the corresponding angle to the side is 109. And then just like up here, your 42-degree angle goes with the 10 kilometers. So that would give you the sine 109 degrees times 10. And this time it's B times this, times the sine of 42 degrees. So when you simplify this side, this will give you 9.46, and this will give you B times 0.67, just like you had up there. When you simplify everything down, this side cancels out. When you divide those, you get 14.12 kilometers. And to find your total distance, you would just add up all your sides. So side A, 7.24, plus B, 14.12, plus C, which was given, 10 kilometers. And if you add those all together, you get 31.36 kilometers. Okay, here is the last problem. Two fire stations are 30 kilometers apart, where Tower A is due west of Tower B. Which tower is closer to the fire and by how many kilometers? So it says the towers are 30 kilometers apart, so we'll put the 30 kilometers right there. And then to find this angle right here, which will be very helpful in finding the other distances with law of sines, if you subtract 14 and 34 from 180, you get 132 degrees up there. So to find the distance of this side length A, you would take the corresponding angle to the side, which is 34, and put that there. And then you would use your given length and the angle that we just found. Oh, I did those backwards. Sorry. Okay, so to find A now, all you would have to do is multiply those. So you take sine of 34 times 30 equals A times the sine of 132 degrees. And then when you simplified this side, sorry, I'm trying to find my work over here, you would get 16.78. And the sine of 132 is 0.74. So once you divide on the other side, you would get 22.68, and that's in kilometers. So that is your distance for A. And then to find your distance for B, again, you use the corresponding angle. So you would use 14 degrees here to go with your side B. And then just like up here, we use our given distance and the angle that we found. And to finish this one, you do the sine of 14 degrees times 30 equals B times the sine, 132 degrees. And when you multiply those, you get 7.26. And B, oh, sorry, B, and again, the sine of 132 is 0.74. And then when you divide those across on both sides, you get 9.81 kilometers for your for the distance of B. So now that we know the side lengths, we have to figure out which tower is closer. So B is obviously a shorter distance, so that means tower B is closer. We're supposed to know by how many kilometers. So you just subtract the distance of A and the distance of B, and that will give you 12.87 kilometers. Kilometers, apparently. 2 kilometers.